All right, let's go over the homework. And I'm going to have to teach you things while we do the homework. Where's my book?
Right here. Right here.
Oh gosh. See, that's what happens when you get old. You just forget stuff. Forget stuff all the time. I make mistakes. Not good.
It's you.
I cannot run as fast as I could.
It's you.
Yeah, but I refuse to accept it. That's why I keep getting injured all the time when I play tennis. Okay, what are we doing? 8.8. Okay, 8.8 are we doing? What are we doing? 8.7?
8.7.
Okay, 8.7. The first one is number 13. Okay, I didn't teach you this, so here. 17. Sine of 3. You know what I was telling the other class? Because the book problems, I don't like them. You know, maybe fourth quarter, I'm just going to write my own problems and just give you guys worksheets to do. No need the book already. You can just read the book if you want to, like if you're absent from school or something. Yeah, right. Okay, now look, sine now. You know how to do this problem, right? Sine theta equal -1, right? Sine of what angle is -1? Okay, do they want degrees or radians? What does it say? They want radians. This is the directions. Theta is between 0 and 2 pi. They want radians. Okay, so can everybody do that? So theta equal 3 pi over 2. See, that's what you got. That's what the quiz is going to be like. You got to know your trig values. Okay, yeah, well, Mr. Park, it says sine 3 theta. So this is how you think. Sine of what angle is equal to -1? Because -1 is a number I'm supposed to know. So sine of what angle is equal to -1? Well, 3 pi over 2. And then how do you solve for theta? How do I get rid of this 3? You multiply both sides by 1/3 or divide both sides by 3. So multiply that by 1/3, you get? Pi over 2. Yeah, well, Mr. Parker, look in the back. They get 3 answers. That's because when the variable is 3 theta, you have to go 3 times around the unit circle. If the variable is 2 theta, you got to go 2 times around. And the reason why is because look, if theta is going to be between 0 and 2 pi, if you multiply everything by 3, then 3 theta, this thing has to be between 0 and 6 pi, which means you got to go 3 times around. So to me, it's a lot easier if you just think, okay, 3 theta, I got to go 3 times around. If it's 4 theta, you got to go 4 times around. 2 theta, 2 times around. Okay, so instead of just giving this answer, 3 pi over 2 is down here, you got to go around another time. How do you go all the way around one time? 2 pi. So what you have to do is add 2 pi to that. 7 pi over 2. But that's only 2 times around. You got to go 1 more time around. So you add another 2 pi. And you get 11 pi over 2. Yeah, but Mr. Park, why do we have to do that? That's because to solve for theta, now you have to divide each of the answers by 3. What happens when you divide this by 3, which is like multiplying by 1/3? 7 pi over 6. Multiply that one by 1/3. 11 pi over 6. Are each of these answers between 0 and 2 pi?
Yes.
Yes. So that's why you have to go 3 times around. So whenever you see like a multiple angle like this, you gotta go multiple times around the unit circle to get all the answers. So that's how you do it. Okay, and then we forgot 13. Where's 13? Oh, that was 13. Why did I write 17? I just don't know. Secant 3 theta over 2. So this is 13. Secant of 3 theta over 2 is equal to, see, I forgot the number already. -2. Mr. Park, I don't like secant. You don't like secant. What did I tell you last time? Change it to cosine. Take the reciprocal of both sides. What's the reciprocal of -2? -half. So if you don't like secant, change it to cosine. Now, is -half a number I'm supposed to know for cosine? What are the numbers you're supposed to know for cosine? Like 1/2, √3 over 2, √2 over 2, 0 and 1, right? Yes, that's one of them. Okay, so what you do is think of this as an angle. cosine of what angle is negative half? Oh boy, let's draw it then. Where is cosine negative half? There and there. What's that one? 2 pi over 3. What's that one? 5 pi over 3 is over here. 4 pi over 3. We don't know our families. Yeah, but Mr. Park, this is 3 halves x. 3 halves theta. So if it's 2 theta, I gotta go 2 times around. If it's 3 theta, I gotta go 3 times around. So what if it's 3 halves theta? Yeah, what is 3 halves? 1.5. So I have to go 1.5 times around. So once I get these two answers, I still have to go another half time around. Like this. So I need another one over here. So once you get this one, you add 2 pi to it. Add 2 pi to that, which is 6 pi over 3. Add 6 pi over 3 to that. 8 pi over 3. Bill, why do I have to do that, Mr. Park? That's because to solve for theta now, how do I get rid of this 3 halves? You multiply both sides by 2/3. So if I multiply this by 2/3, you can get 4 pi over 9. Multiply this by 2/3, 8 pi over 9. Multiply this by 2/3, 16 pi over 9. That's why you have to go 1.5 times around, because you're going to multiply each of those answers by 2/3. Now, I know you guys don't like fractions. That's why I don't like the book problems. So on my quizzes and tests, I'm only going to give you 2 theta, 3 theta, and 4 theta. I'm not going to give you like 1.5. Okay, so you guys can remember that. Don't worry, because it's not going to be, this stuff is not on Thursday's quiz, but it will be on the test, but I'm going to give you the practice test, right? So you'll learn how to do it then if you haven't picked it up yet. Okay, 25, 27, 29. No, 25. Okay. This, if you get a problem like this, you gotta pounce on it. You gotta pounce on this thing. Like on the test, I don't think I'm gonna even give you a problem, even that, no way that easy. Okay, so we gotta isolate the cosine theta, so take this 2 and move it on that side. So what do you get? Subtract 2 from both sides and you get? -3. How do I get rid of this 3 root 2? Divide both sides by 3 root 2. So, gunga. Cosine theta is equal to, these cancel out and you get -1 over root 2. Is that a number I'm supposed to know for cosine? Yeah. So now you just think, cosine of what angle is -1 over root 2? Okay, let's draw the picture again. I don't even see the arm movements. Where is cosine -1 over root 2? There and there. So what is that? 3 pi over 4. That's this, and 5 pi over 4. There you go. Now we're talking. This is what the quiz is going to be like. It's all problems just like this. So if you don't, okay, if you want to pass this next test, you want to go do, there's one test left in the quarter. When is it? Next week?
Wednesday.
Next week. Is it Wednesday? Yes, it's Wednesday. What do you have to know? You gotta know your unit circle and you gotta know your identities. That's what you gotta know. If you don't, then it's gonna be pain because I am not adjusting this next test. Okay, so that's 25. Okay, next, 27. Okay, you know what? 27, 29, I changed my mind. Just cross them out. We discussed it in another class. I'm not gonna give you that. Okay, so let's do one more practice then. I'm just going to make up a problem now. Tangent 2 theta is equal to, give me a number, 1 over root 3. Okay, this is what you can see on the test. Okay, so you see this. Is this a number I'm supposed to know for tangent?
Yeah. Yes.
Okay, so this is what you think. Tangent of what angle is 1 over root 3? So what are you thinking? Correct? What's this one? 5 over 6. What's this one? 7 pi over 6. Okay, but there's a 2 theta here, so what do? You gotta go twice around. See, this is only once around. So what you have to do is you have to add 2 pi to each of these. Now 2 pi is 12 pi over 6, right? Add 12 pi over 6 to that. and then add 2 pi to that, which is 12 pi over 6. 19 pi over 6. So to solve for theta, you have to divide both sides by 2, which is like multiplying by a half, right? Multiply that by a half. Multiply by a half. Yeah. Yeah. Boom. Can you guys repeat that on the test? Well, don't worry. It's not like I'm going to spring it on you. It'll be on the practice test. And again, I make the practice test first. Let's assume this is on the practice test. Then, you know, on the real test, you know what I do? Just change that to a 3. Then you got to go 3 times around. If you can go 2 times around, you can go 3 times around, right? Or I change the tangent to sine and change this to root 3 over 2. But it's the same type of problem. That's how I help you. Okay, 41, 43, and 45. Now, I didn't realize that this was on, I thought it was on today's lesson, but it was on the last lesson. That's why you guys don't know how to do it. But you guys read the book though, yeah? Yeah, right. Okay, so let's do 41. Number 41. Sine theta equal 0.4, and they want their answer in radians. You know how you can tell? Because it says this. That's why they want radians. So sine theta is equal to 0.4. Now, is this a number I'm supposed to know for sine? No. So the only way you can do it is by using your calculator. So take out your calculator. Or if you don't have it now, then you watch the video again, and then, because that's the only way you can do it. Now, before we start, how many answers are there going to be? 2. Because sine is positive in what 2 quadrants? 1 and 2, right? So there's going to be one angle here and another angle there. So you should have 2 answers. Okay, now, take out your calculator, put it in radian mode, because they want radians. So change the mode to radians on whatever calculator you have. Okay, now, how do I figure out the sine of what angle is 0.4? You would look for this button on your calculator, sine inverse. Anytime you want to find the angle, that's what you use. So that's called sine inverse. Okay, look for this button and then punch this in right there. Sine inverse 0.4. Sine inverse, where's my sine inverse? Sine inverse 0.4. Bam. I get 0.412. Now remember, if you use your calculator, you always round to 3 decimal places. Did everybody get 0.412? Got to be in radian mode now, because if you're in degree mode, it's going to give you something else. Okay, now, this angle is a first quadrant angle, so that's one of the answers. So this angle here, that's the one in the first quadrant right there. But you need the one in the second quadrant as well. So if you know the first quadrant one, how do you get the second quadrant one? If this is 0.412, that means this angle here is 0.412. How do I get the angle going all the way around to here, like that? This angle there. You what? You what? Subtract what? Yeah, you go pi minus that. So here, let me make a chart for you so you can just follow. So if you're looking for a second quadrant angle, then you go pi minus that angle. Or if you're in degree mode, you go 180 minus the angle, okay? If you're in the third quadrant, if you're looking, here, to draw another picture. If you're looking for the third quadrant angle, then what you do is you go pi plus that angle. So you go pi plus the angle. And if you're working in degrees, you go 180 plus the angle. And then if you are in the fourth quadrant, which is over here, like if you know this angle there, how do you get the one off going all the way around to there? You go 2 pi minus that angle. And if you convert it to degrees, you get that. Here, so put that in your notes. Now I'm not sure if the book has it or not, but that's what you gotta do. So once you figure out the first quadrant angle, the book calls this the reference angle. How do I get the one in the second quadrant? What do I do? What does it say right there?
Pi minus angle.
Yeah, you go pi minus that. And then you punch that in on your calculator. Now the other class said, Mr. Park, I can't find the pi button. Well, if you can't find the pi button, we all know that pi is 3.14159, right? Okay, that would be good enough. So 3.14159 minus 0.412, kutoosh! 2.730, rounded off to 3 places. Those are your 2 answers. Okay, let's do, so this is number 41. Let's do the other one, so hopefully by the end you can get it. Okay, 43 now. Okay, what is 43? Tangent theta is 5. Okay, is 5 a number I'm supposed to know for tangent? No, so we gotta use calculator. So before we even start, you gotta figure out, this is positive 5. Tangent is positive in what 2 quadrants? The first and the third, okay? So how do I get that first quadrant angle? What do I punch in? Tan inverse 5. That's gonna give you the one in the first quadrant. So on your calculator, you punch in tan inverse 5. Boom. You get 1.373. That's the one in the first quadrant. So if I know the one in the first quadrant, how do I get the one in the third quadrant? What does it say on this chart here? Pi plus that. So you go pi plus 1.373, and then you punch that in your calculator. So 3.14159 plus 1.373, katouche, and you get 4.515. Boom! Those are your 2 answers. So you guys understand what to do? So first you find the reference angle, and then depending on what quadrant you're looking for, you either subtract it from pi, you add it to pi, or you subtract it from 2 pi. Okay, let's do 45. Hopefully we're getting the hang of it. 45, cosine theta is negative 0.9. Okay, now, negative. Now, cosine is negative in what quadrants? Where is cosine negative? Second and third quadrant, so you're gonna have 2 answers, okay? Now, when you find the reference angle, remember the reference angle is the one in the first quadrant. So to find the reference angle, you punch in cosine inverse positive 0.9. You don't put the negative sign. Anytime you're finding the reference angle, you just use the absolute value of that number. So punch that in on your calculator. Cosine inverse 0.9. 0.451 radians. That's the reference angle, okay? So, how do I get the angle that's in the second quadrant? If you use the chart? Pi minus that. And how do I get the one in the third quadrant here? Pi plus that. Okay? So if you punch this in on your calculator, 3.14159 minus 0.451, 2.691. And then this one, 3.14159 plus 0.451, 3.593. Those are your 2 answers. Okay, you got the hang of it? Okay, I'm going to give you one more problem. Let's do degrees now. Okay, so first, change your calculator to degree mode. Okay, so solve for theta. Theta is between 0 and 360 degrees. Okay, so let's do something we haven't done. Cosecant. Cosecant theta is equal to, let's do negative, give me a number.
2.
Okay. No, because then sine is negative half. That means you don't need a calculator. 3 then. Mr. Park, I don't like cosecant. Then change it to sine. This means the same thing as sine theta equals negative 1/3, right? The reciprocal of 3 is 1/3. Now, is 1/3 a number I'm supposed to know for sine? No, 1/2 is, but not 1/3, so you need your calculator. So first I find the reference angle. How do I find the reference angle? What do I punch in? Sine inverse positive 1/3. So punch that in your calculator. So I'm in degree mode. So sine inverse 1/3. I get 19.471 degrees. Did everybody get that? That's the reference angle. Okay, now, sine is negative in what two quadrants? Where is sine negative? Third and the fourth. So how do I get the one in the third quadrant? Go 180 plus that. Just follow the chart right here. How do I get the one in the fourth quadrant? What does it say? 360 minus that. So you go 360 minus 19.471 degrees. And we can punch it into the calculator, right? In fact, come on, we don't even need a calculator. Look, 199.471 degrees. Now this one might be difficult because you're gonna have to borrow. Yeah? Can you guys borrow? Well, if I'm gonna let you use a calculator, why even risk it? Just punch it in. 360 minus 19.471. 340.529 degrees. So that's how you use your calculator to solve trig equations. Not that difficult, is it? Okay, tonight's homework. Hey, how come we finished faster than other class? Okay, but see, this is what I'm worried about. Because if you don't have this skill down, you're not gonna be able to pass this test. And this is the last test of the quarter. Some of us, when I give you your quarter average, your current average, some of you are gonna realize the gravity of the situation. Like this, tangent theta equal -1/√3. No, we already did that one already. Tangent theta equal +√3. This is what the quiz is gonna be like. Tangent of what angle is √3? What are you thinking? So what is that? /3. And what's the one down here? What about the rest of us? Just nod our head. This is the skill that you need to pass this test. You have to know your unit circle. So get out your unit circle and study again. That's what happened. Okay, now tonight's homework, the problems, you're still solving equations, except now you gotta use identities. Woo! So here we go. Solve for theta. Theta is between 0 and 2 pi, which means we want radians. You know what? I'm just going to do the examples from the book, because the examples from the book were pretty good, actually. But then you guys don't even read your book yet, so you guys don't even know. 2 sine squared theta minus 3 sine theta plus 1 equals 0. See how it looks a little more difficult than the ones we did last time? So how do you solve an equation like this? What do you do? Well, notice that, doesn't this look like a quadratic equation? Okay, let's go back to algebra 1. What if you had 2x squared minus 3x plus 1 equals 0? How do you solve quadratic equations? What do? You make one side 0, and then you try and factor it. What happens when you factor it? Let's see, 2x and x, 1 and 1, minus minus. Is that correct? Okay, so if something times something equals 0, that means either this one is 0, what will make this thing 0? What can I plug in for x to make that thing 0? 1/2. What about this one? 1, and there's your two answers. You can treat this the same way, except instead of the variable being x, it's now sine theta. So what you do the same thing. You factor it just like a quadratic. So you go 2 sine theta, right? Because isn't this times this 2 sine squared theta? And then now you think, what times what will give me 1 here? Well, it's got to be 1 and 1. And then you just have to figure out the correct signs, and you go minus minus. So outside, inside, do I get -3 sine theta? Yeah. Okay, so if something times something equals 0, that means either this one is 0 or that one is 0. What would make this 0? Sine theta would have to be, no, sine theta. No, make that 0. Sine theta would have to be 1/2. And what if I said that one equal to 0? Sine theta would have to be 1. See, it's exactly the same thing as this, except instead of x, you have sine theta. Okay? Now, are these numbers that you're supposed to know for sine? Yes, that's the skill you gotta have. Sine of what angle is 1/2? What's this one? What's this one? Okay, and then sine of what angle is 1? Pi over 2. Boom, problem done. Okay, next example. Okay, that was an easy example for tonight's homework. Now it gets a little tougher. 3 cosine theta plus 3 is equal to 2 sine squared theta. Now, the difference between this equation and that one is, see, this one, everything is all sines. There's only sine theta here. But in this one, you got cosine and sine. Your goal is to make everything just one, either sine or cosine. So how do I do that? How can I make just everything just either sine or make everything cosine? You have to use identities. Like sine squared theta. What can I do with that? There you go. 1 minus cosine squared. Oh, so Mr. Park, I gotta know my identities then. Yes! That's why we studied that. So if you multiply out everything, you get 3 cosine theta plus 3. Distribute the 2 here, alright? So you get 2 minus 2 cosine squared theta. Hey, this is a quadratic, Mr. Park. Yeah, so how do you solve quadratics? Make one side 0. So put it in order. 2 cosine squared theta plus 3 cosine theta. Subtract the 2 and you get plus 1. Now that problem looks like this one. But you have to use the identity before you start. And then, now, if I'm making the problems and I'm not letting you use a calculator on the test, then this thing had better factor, okay? So 2 cosine theta, right? And then look, that's a 1, so that's gotta be a 1 and a 1. And everything is pluses, so gotta be pluses. Is that correct? Is that correct? Yeah. Okay, so now we have it into the form we want. If something times something is equal to 0, that means either this is 0 or that is 0. What would make this factor 0? Cosine theta would have to be -1/2, and that one, cosine theta, would have to be -1, and those are numbers I'm supposed to know. Okay, cosine of what angle is -1/2? What's that? What's this one? What about this one? Very good. Cosine of what angle is -1? Right. See, some of us are good at it, I can tell, and then some of us are just not. Because we don't know. Okay, and then the problems get even tougher, if you can believe it. Okay, let's do another one. Sine 2 theta is equal to cosine theta. Now, what do you think I'm going to do with the sine 2 theta? You got to use identity. So when you see sine 2 theta, cosine 2 theta, or tangent 2 theta, you got to use the double angle identity. What if you saw sine theta over 2? Then you got to use the half angle identity. So yes, you still need to know your identities. What is the identity for sine 2 theta? Very good. Okay, if you don't know it, then you're out of the problem already. Okay, now what do I do? Can I divide both sides? Can I cancel out the cosine thetas? No. Well, yeah, you can, but then you just lost half the solutions. Therefore, I have to take out 8% of the points. Look, let's go back to algebra 1. If you have an equation like this, x squared equals x, can I divide both sides by x and go, x equal 1? No, you just lost the solution by doing that. How are you supposed to solve quadratic equations? You make one side 0, you factor it, and if something times something is 0, that means either this one is 0 or that one is 0. See how you get two answers? So if you divide both sides by a variable, what's happening is you're losing solutions, which is bad. So you never cancel a variable from both sides of the equation, never. So what do you do then? You bring it over, you make one side 0, like this. Make one side, look, anytime you're solving an equation, if you don't know what to do, just make one side 0, you'll be going in the right track. And then what do? You factor it. What can be factored out from both of these? Cosine theta. 2 sine theta minus 1. See, now we got it into something we can work with. Something times something is equal to 0, which means either this one is 0 or that one is 0, which means sine theta is, what would make this 0? Sine theta has to be 1/2. And hey, these are numbers I'm supposed to know, that's right. Okay, so here we go. Cosine of what angle is 0? Boom! What's this one? 5/2, what's this one? There you go. See, some of us got the hands down, what about the rest of us? What are we waiting for? Sine of what angle is 1/2? What's this one? 5/6. And you know why we can do this? Because we know our unit circle. I tried to get you guys to know the unit circle at the very beginning of the class, but no, Mr. Park, I don't want to. But now you can see, if you don't know it, you're in big trouble. You gotta know it. Okay, let's do another. Let's increase. Cosine 2 theta equals sine or cosine? Sine or cosine, pick one. Okay, now, Mr. Park, cosine 2 theta, get 3 identities. Which one should I use here, since there's a sine on that side? Because you want to try to make everything all just one variable, right? Yeah, the one with sine, right? Since that's sine, you use the one with sine. If this was a cosine, then you use the one with cosine. So, which is the one with sine? Okay. There you go. Hey, it's a quadratic, so then you make one side 0. So, whenever you do quadratics, well, this is what I do. I always like to have my first term positive. It's just easier to factor that way. So, how do I make this term positive? You move it to the other side. So that's why I made the left side 0. And then hopefully, well, if Mr. Park made this problem, then it's going to be factorable. 2 sine theta, right? 1 and 1. And let's see, this is plus, that's minus. Did I do that correctly?
Yes.
Of course, I'm the teacher. So, if something times something is equal to 0, that means either this one is 0 or that one is 0. What would make this thing 0? Sine theta would have to be 1/2. What would make this factor 0? -1. And those are all numbers I'm supposed to know. Okay, so sine of what angle is 1/2? How many times have we done that one today already? What's this one? Okay, I'll answer my question. 5/6, 5/6. Sine of what angle is -1? 3π/2. Finished. Okay, let's do one with tangent now. And then last example and we're done. Tangent 2 theta equal tangent theta. Let me think, is this one gonna come up? No! I think I need to put a 3 there. Okay, well, let's just try that. Now I'm looking at tangent 2 theta, what should I do? Use the double angle identity, which is 2 tan theta all over 1 minus tangent squared theta. Wait, by the way, how many people didn't take yesterday's test? Wagner? How come the other class had like 3 people? Anyway, okay, let this be a lesson. You miss a test, I'm assuming you're coming the following morning. That's why I come at 6:30. If not, I'm waiting for an email of some sort or something. Okay, anyway. So tell me when you're gonna make up the test. No, that doesn't have to be done. Okay, how do I solve an equation like this? What do you do? When you have a fraction, what did your teacher teach you in Algebra 1? Multiply both sides by the least common denominator, which is 1 minus tangent squared theta. So if I multiply both sides by that times this to cancel out, so you get 2 tan theta, equals, and what happens when I multiply it by this? You distribute and you get 3 tangent theta minus 3 tangent cube theta. Oh yeah, this is gonna come up. So again, making one side 0, you get 3 tangent cube theta minus 3 tangent theta, so minus tangent theta. Okay, now how do I solve an equation like this? Is this factorable? What can I factor out anything? Yeah, you can factor out a tangent theta. What's going to be left? 3 tangent squared theta minus 1. So now we got it in a form we can work with. Something times something equals 0, which means either this is 0 or this is 0. Well, now what would make tangent theta 0? We talked about this last time. Okay, if you can't see it, then go on the side here. 3 tangent squared theta minus 1. What would make that 0? Add 1 to both sides. Divide by 3. Oh, squared. And then square root both sides. So what happens when I square root both sides? You get plus or minus. What's the square root of 1? What's the square root of 3? And where did this plus or minus come from again? The absolute value. Because remember, when you square root something squared, you get the absolute value of x. That plus or minus comes from that absolute value. Okay, so tangent theta is plus or minus. So if you have to go on the side and figure it out, then figure it out. But look, these are all numbers you're supposed to know. Tangent of what angle is 0? 0, pi, and what? Yeah, so 0, pi, and 2 pi. And then what about this? Tangent of what angle is either plus or minus 1 over root 3? So what is that? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Oh, Mr. Park, it's 7 answers. Yeah, it still happens sometimes. So yeah, tonight's homework, it's the same kind of thing, but you gotta use identities. It's a little tougher. I would say the biggest portion of the test is gonna be solving problems like this. Tonight's homework, very important. Okay. So if you didn't take the test, you can go outside. Oh, we gotta go backwards. We gotta go to 8.1. Interesting. Okay, here's the test. So I graded the test. Oh wait, let me turn off this camera. We can't be going over the tests on film.